Your conference is being recorded. Brian, I assume you're on the line?
Yes, sir.
All right, I see your screen, so we are good to go. All right, according to my clock, it just switched to 2 o'clock, so we'll go ahead and get started. Again, my name is Steve Marzos. I'm the Integrated Services Program Director for VITA, and this is part of our continuing Webinar Wednesday series. Today we're going to talk about the NENA Standard for GIS data, and we have Brian Crumpler who's going to present that. I would also be remiss if I didn't thank Melissa Parsons, who's the regional coordinator in the Roanoke area, and she's been the one that coordinates these Webinar Wednesdays. So if you have ideas for other Webinar Wednesdays you think we should cover, or if there's a particular topic we should cover in more depth that we've already covered, please let Melissa know. We do have a number of them coming up that we're going to be planning over the next couple months, and again, these are to help you with the jobs that you do and have to do every day. So we want to make sure they're valuable and a good use of your time. The amount of participation we've had over the last few months of doing these has been wonderful. So we hope that you are finding value, and that's why you keep coming back. But if there's something else that we can do, a little different, a different topic, please let Melissa know, and we'd be happy to satisfy that request. With that, I will remind everyone, please, again, mute your line, *6 to mute, #6 to unmute. If you want to do it through the conference bridge, or you can just do it through your telephone. And that way, if you do have a question, please feel free to interrupt Brian and ask the question as we move forward. So with that, I will turn it over to Brian, who's our regional coordinator up in the Northern Virginia area, to talk about the GIS data standard from NENA. Go ahead, Brian.
All right, thanks, Steve. Good afternoon, everyone, and again, thank you for your time this afternoon to learn more about the NENA standard for the next generation 9-1-1 GIS data model. NENA has just released the standard, not the official standard yet, but this is the first round of public review. Again, today we're going to be passing on a lot of information about what's in the standard, how to provide comments for proposed suggestions, changes, clarifications, etc. But with that said, let's go ahead and look at what we're going to be discussing today through the call. So some of the items that we're going to be going through today are going to be looking at what the next generation data model standard is, what's the basic structure of the document, looking at the GIS data layers that are needed within a next generation 9-1-1 system, looking at the actual technical structure of some of the GIS data layers, looking at some items that the GIS data model work group has chosen to defer for future work, but that they know that they need to address in the future. Also looking at how next generation 9-1-1 GIS data is used within next generation 9-1-1 systems and functional elements. Looking at the current status of the standard and the additional steps that will need to be taken before it becomes an official finalized version of the standard. And then finally, how to participate in public review and provide your comments as part of the public comment review period. And then finally, some information about some other related NENA GIS related standards. So to start off, the first question that we need to ask is, well, what is the next generation 9-1-1 data model? NENA standards. NENA provides different guidelines, standards, best practices, lots of different types of documents that are published by NENA. So within NENA's documentation, they have what's called SA documents, which are standards-based. So anytime you see an STA in front of a NENA document, it's a standard. So the GIS data model is going to be denoted as SA 006 for the GIS data model. It defines the GIS data layers within a next-generation 911 system and provides guidance on formatting of GIS data prior to use within next-generation 911 systems. Some of this will apply towards validating locations, geospatial call routing. In the future, will also be used for dispatch routing and public safety mapping applications. And so whenever the GIS data model work group decided to create this GIS data model and the standard, they were looking at an all-encompassing view of how GIS data would be used within a next-generation 911 system. The data model will also allow backwards compatibility to tie to legacy and existing 911 systems. That was something that was extremely important because there will be times where you may upgrade, say, a call handling system, but a CAD system or a records management system or some other systems that you have in a PSAP may still be using legacy fields and legacy information. So the data model needed to be able to support both the future with next generation 911 plus the legacy fields. It also looks at the required data structures for GIS data exchange within a next generation 911 environment. And then also it addresses the daily maintenance of GIS data. One of the concerns that people have with data standards of many different flavors is that it asks the question, well, does this mean I need to change how I maintain the data in my county system or in my PSAP? Well, there may be a benefit to changing and adopting, but ultimately, at the end of the day, the data needs to be stored in a way locally that allows you to be able to export it to the next generation 911 data model in order for it to go into the system. So you can maintain your data a different way, but you've still got to be able to have some way to be able to translate your data. And that's what the next generation 911 data model does, is it gives a template for loading data into the next gen systems. So this document, so the GIS data model document, it's a part of a series of different NENA standards and best practices that have been released over the past several years. So the main guiding document that NENA has for looking at next generation 911 is this document called SA 010. You may have heard of I3 or the I3 standard. And that's what's in that NENA Standards document 010. Within that, there's an appendix that talks about how GIS data will be used by functional elements and key components within the next generation 911 system. So that Appendix B talks about how, say, a 911 vendor in NextGen would have to store and use that data. The GIS data model talks about how data is to be provided from a locality or from a PSAP to something called the spatial interface and to a spatial interface operator. And during that process, it would translate the data from the data model to the data required by the I3 system in NextGen. So what the GIS data model does is it helps to standardize the fields, the attributes, the required elements that are needed in order to correctly populate the system so that it works correctly within next generation 911. So within the document, you've got about 8 key sections. Not all of them are going to be shown, not all of them are going to be relevant to everyone, but within the document, you've got an executive overview, an introduction, some technical and operational descriptions, the different GIS data layers that are included or needed within the data model, It has a description of field names and associated attributes. It has a link to information on what NENA calls their NENA registry system, which is basically a domain of a list of different values that are accepted values whenever you're trying to populate your data. And then finally, some recommended reading and reference links to other documents that are out there. So as we go through here, we're going to go not every single section, but we're going to have some breaks throughout the webinar for each of these sections. So if there's questions, as Steve said, if there's questions as we go along, please feel free to chime in and ask a question, or if you want to wait till the end, that's fine as well. But we can definitely have breaks in here to answer questions if there are some that come up. So the first item that we're going to look at is the list of the data layers. Within the GIS data model, they have data layers that are broken down into required data layers, strongly recommended data layers, and optional data layers. Within this, just please note that the layers here are depicting what is currently listed in the draft of the document. Again, this may change after going through the feedback from the round of public review. But again, as of today, this is what's listed in the document as it currently exists in the draft version. And the following GIS data layers are required in the draft based on what's in the draft. So currently it requires road center lines, PSAP boundaries, emergency service boundaries, which would be law, fire, and EMS. And these layers are listed in the data model as being needed for location validation to basically ensure that a location is actually in the real world. To look at emergency call routing function, which is what's used to route a call to the correct PSAP or 911 center. This will be used for call taking and also for dispatch operations. And again, these are some of these layers in here. Like I know people see emergency service boundaries, and that may be something that may be new to people as required. The GIS data model requires it because those are data layers that were previously required in other 911 systems and other data models within legacy 911. So again, the GIS data model isn't just looking at call delivery; it's looking at many different components of 911 systems in the next generation environment. Moving ahead to the strongly recommended layers, there are a lot of other types of layers that are shown here. Again, these are not going to be required, but in many cases they're going to be very, very strongly recommended. And in most cases, many cases these may assist or to help with functionality of the location validation or the call routing functions. And it could also be beneficial for call taking and dispatch operations. But again, these weren't required fields, at least not in the first version of the data model. So some of the items that you may see in here that may look familiar are going to be things like counties, states, city boundaries, incorporated municipality boundaries, which would be in Virginia would be the the city boundaries and the town boundaries, but also other types of service boundaries. For example, poison control, Forest Service, state police, Coast Guard. So there are other types of responding agencies that could have GIS boundaries, and those data sets could be loaded in to the next generation data model schema and forwarded onto the 911 network. Again, these are not required layers, but they're layers that could be very helpful throughout the response for various 911 calls. And then finally, NENA is recommending additional data layers here. So you've got things like railroads, water bodies or hydrology, information on the locations of cell sites and or mile markers. And again, these are layers that may be very useful and helpful, not only for next generation 911, but many PSAPs today may already have many of these layers in their 911 systems. So before we move on to the next field, looking at how the GIS data model schema and the fields and the values were put together, wanted to hit on a new acronym that it's relatively new to many people. NENA published about 2 years ago a document called the Civic Location Data Exchange Format. And so you may see an acronym called CLDXF. And basically what this is, it's a common means for PSAPs to share and exchange 911 call location information. This aligns with existing Internet Engineering Task Force documents and standards, which basically govern how information is shared in an Internet or an IP-based network back and forth. So this CLDXF document, the CLDXF document was a standard that really guides the use of how location fields are to be filled out and populated, which location fields are needed in order to have a valid 911 address. It includes information on clarification of things like spelling and punctuation and spelling out names. So, for example, in legacy 911 world, you may or may not have to spell out a street name type. It could just be an RD stands for road, PL stands for place, etc. But in CLDXF, that standard actually requires someone to spell out the names for street as STREET, or way would be WAY, etc. And the idea behind this is so that there's no ambiguity whenever you're trying to match or validate an address. You know it's an exact literal match, and it's spelled the exact same way, and the data that's coming from a local phone company with an address matches exactly to the GIS data. So whenever the NENA work group was putting together this data standard, one of the things that they were looking at aligning was making sure that the CLDXF required fields were also then the required fields that they have in the data model. They also wanted to make sure that they had the names of the fields. So, for example, if it's a street name, they want to make sure street name in their table shows up the exact same way as street name shows up in the CLDXF document, and also the exact same way that it shows up in the I3 standard. So it's NENA's done a really good job with their data fields to make sure that they align with one another, and they've taken a lot of time to reduce the ambiguity in the field names and what information is needed, and they've done a good job with spelling this out. And so for an explanation of the columns that are here, we're going to explain that here in the next slide. So within each of the tables, for each of the types of data layers, so for example, within address points, you would have a separate table for address points. Center lines would have a different table with the different fields it needs, et cetera, et cetera. So each GIS layer would have each of these fields. They would have a descriptive name. They would have a field name, which standardizes the name for the GIS attribute. One thing that they did was they made sure that this was 10 characters or less. So for GIS data sets, sometimes some different file formats that GIS data is stored in can only hold a field of 10 characters or less. So whenever they were creating this data model, they wanted to make sure that regardless of what format, if it's a shapefile or some other database format, that the field names would still be the same regardless of what format you used. So that was one item that they wanted to add in here. Also, they put in fields for mandatory, conditional, and optional. A mandatory field is an attribute value, means that the attribute must be filled out for that data field. Conditional would mean that if an attribute exists, then it must be populated, and if it doesn't exist, then it would be blank. And optional means that if it's something that would be up to the discretion of of the community for the PSAP whether they want to populate that or not. So if I go back to the previous slide for a second and look at some of these fields, some of the mandatory fields that you have are the source of the data, meaning where did it come from, the date it was last updated. For center lines, what's the address range on the left side, from the low to the high on the left side, the low to the high on the right side, and then what's the street name. Those are all items that are mandatory fields currently in the data model. And then items like a prefix directional, like north in the north, for example, in North Main Street, north would be conditional, meaning that not every street has a north, but if it has a value, if you have a street with a north in it, you would put the value of north in that field, and if it doesn't have a value, then it would just leave it blank. So that's what conditional would mean here. The next two items that they have are the type of field. So this is also to help standardize the values that are going into a field to make sure that whenever they're loaded into the next generation 911 system that there are no issues and the information is formatted correctly. So the four types that they have in here are text, which again could be free text, a date and time fields. So there's a specific internet standard, ISO standard for how that should be formatted, and again that's clarified in the document. But date and time fields are all to be formatted that way. They have an F for floating number fields, which are values that have a decimal place, and then number fields, which are whole numbers. And then finally, they have a field for field width. So, for example, in a state, if in a field for a state, the value would have a field width of 2, in which case you would want to have the abbreviation for the state, VA for Virginia, NC for North Carolina, et cetera. One of the notes that the GIS Data Model Working Group did provide is that field widths were made intentionally to be pretty large. So if you do have any real-life examples where a name of a field, so for example, street name here is 60 characters. If you have a street name that's longer than 60 characters, then please definitely submit a comment for the GIS data model to know this is a real street name. It has value of 60 characters, and please increase the value from 60 to 75, or make some sort of a suggestion like that, so that the actual street name that you have in your community would be represented accurately within this data model, and it wouldn't be cut off. All right, moving ahead to the next section. Within Section 5 of the document, they go through and they actually provide definitions for all 138 fields. So all the different fields that they have for addresses, for roads, for PSAP boundaries, for other service boundaries, for state boundaries, cell tower locations, railroads, every single one of those fields is listed here in Section 5 alphabetically. So in the screenshot, you see the source of the data, speed limit, and state. Those are 3 examples of fields that are in there. And again, there are 138 of them currently. Each one of these has a description, an attribute domain, which gives possible values that could be used to fill in the field. It also gives example. So one good example of this where I was able to provide a comment for clarification in the previous version of the data model that was out for review by NENA workgroup members is in the county field, there was not a clear means of describing how the county field should be populated. So previously in the data model, they said that county could be, so like for example, I'm in Spotsylvania County. County could be Spotsylvania. County could also be Spotsylvania County. And there would be an ambiguity of how it should be populated. Because of the comment that was suggested and the discussion of the work group after that, they were able to resolve that and standardize counties so that it uses the name of the locality, in that case Spotsylvania, and then the name of the type of jurisdiction. So in that case, it would be county. So it would be Spotsylvania County. If it was Richmond City, it would state Richmond City. Fairfax County would be Fairfax County, and Fairfax City would be Fairfax City. And so that would be standardized. So in that example, they were able to identify the values that are acceptable and then also provide the link, in that case, to the U.S. Census site, which maintains a list of cities and counties across the country as the acceptable list. But that's a good example of the types of comments that they're looking for as a part of the data model to make sure it gets clear so that both PSAPs and GIS offices at the locality level, as well as 911 implementers and service providers, know how each of the attributes should be populated correctly. Before I move on to the next section, are there any questions or comments so far?
Hey, Brian, this is Steve Marzoff. I do hear some background noise. Somebody's mic is unmuted that sounds like might be eating. So if you could mute your line, I would really appreciate it. It's just a bit distracting. And the other thing that I'll mention, because I'm going to have to drop off the call, is we in Virginia haven't decided exactly, as Brian said, this isn't finalized yet, so we haven't decided exactly how we're going to or if we're going to adopt it, and that would be the 911 board who has the standard setting authority for Virginia. Just because NENA says it's a standard does not mean it's a standard that we all have to follow. It is a suggested standard from NENA and one that they offer for states or localities to implement if they so choose. As an example, one area where we know we're going to differ already is we have said that the 911 board has provided funding for address points and as a mandatory. Rather, it's a highly recommended from NENA, but we felt strongly, or the 911 board felt strongly, that it needed to be part of the base configuration or base standards. So for next gen 911, because we've had such quality data in Virginia, that we could do that. So keep that in mind as we move forward, that this is still in the developmental stage, and as Brian said, this isn't the point where you go out and start making changes to your data to match this, because we'll then have to, once it's implemented or accepted at the NENA level, is determine how we're going to implement it at a Virginia level as well.
Yeah, and to build on what Steve just said, the NENA work group that's responsible for building this standard, and again, we're going to have a slide on this later on, but they've been in the process of developing the standard for the past 6 or 7 years. And I think the first 2.5 years were developing it, and then they had another 2.5 or 3 years of responding to and resolving all of the comments that were suggested from internal reviews by other NENA work group members. So it's taken 6 years just to get to the first phase of public review, and it could be 2 or 3 phases of public review as well. So you could still be several years out from having a finalized standard on this. And so, again, as Steve said, as a Commonwealth, 911 board will have to make a determination of what we're willing to do for Virginia. But this, again, at least gives a foundation and a head start on looking at what might be required and or what might be helpful as people start to deploy. And again, the other point with this is that some of the required fields that they've listed in this standard may be required for certain functions. For example, if we're looking at 911 call delivery and replacing how 911 systems are delivering calls to PSAPs today, there may be a subset of these fields or a subset of these features and data layers that are needed for that specific phase of transition to next generation 911. There may be other items that might be needed whenever you're looking at call response or other components within a PSAP. So again, depending upon what layer we're talking about, that'll all get flushed out as we move ahead as well, as these standards get more mature. Thank you, Steve. Also wanted to put in a slide here. They do have a section for future work. One of the benefits of NENA including a future development section in their standards documents is that it provides insight on where they're thinking they might go next. There's a lot of discussion about vertical accuracy for 911 calls. There are questions about site structure address points versus site structure polygons, such as building footprints or parcels, and how those might be used differently. And again, this screenshot, it just shows a list of about 10 or 15 different items that the NENA work group has identified as needing to be resolved at some point. But again, in order to get this document out for public review and to get an actual standard developed and published, they've chosen to defer these items for future work. Also, within next generation 911, the GIS data is used in a number of items that are called functional elements. So within this, we've got 5 key functional elements that the GIS data model has said that the GIS data will be used for, and we've broken this down into 2 different slides. The first one is this thing called Presence Information Data Format, called PIDFlow. Again, you may hear that on different presentations or see it in different acronyms. But basically, it's a data format to be able to communicate location information electronically through different systems and be able to exchange the information. It's consistent with the GIS data model and CLDXF, which we talked about earlier. It also talks about how to handle sub-addressing, but that's one item where the GIS data will be used and takes into account. The other 2 items that you have are called the location validation function and the emergency call routing function. The ECRF, or the emergency call routing function, basically tells, it helps deliver, or it says which PSAP should receive a call and routes the call to that right PSAP. So that's the actual function that handles sending a call to the right PSAP. But before that ever happens, addresses from your local telephone company, it might be a Verizon, it might be a CenturyLink, it might be a VoIP provider, those civic addresses for where the subscriber numbers are located, those are all validated against the GIS data through this thing called the location validation function. And it looks at whether each field is a match, in which case it's valid. If there's a case where it's a mismatch, where it's invalid, or if it's something that's unchecked because it's not able to check the data. So this is extremely critical because the way that 911 calls match address data is very different with the next generation 911 compared to how it's handled today in the MSAG and the alley. In next generation 911, it goes field by field through each of the elements within the subscriber address, and then it tries to match that field for field to the GIS data. So like if I've got 101 Main Street, Chester, Virginia, it's in the U.S., it would look at country and say, does U.S. match to a GIS record that has somewhere in the U.S.? Yes, it does. Does it match to Virginia? Does it match to county is equal to Chesterfield? Does it match to unincorporated town is equal to Chester? Or MSAG community or postal community is equal to Chester? Does it match up to Main Street? And does it match, do I have a GIS feature that also says 101? And if there's a unique record, like an address point or a centerline segment that matches that directly, then that will be a valid record. If there's any of those fields that don't match exactly, so for example, if I've got Main Street and the local telephone company thinks Maine is spelled with an E at the end, like the state Maine, but the GIS data says Main Street MAIN, it will have a mismatch, and it will then return back what's called an invalid record. So why that's so important is for each of you that have heard some of the previous webinar Wednesdays that we had one a while back that looked at the statewide MSAG alley GIS analysis. And some of the checks that were performed in that were to look at the synchronization of the GIS data to the ALI and to the MSAG to be able to make sure that they're in sync and to provide feedback on where they're not in sync. Within Next Generation 911, this location validation function is going to provide reports back on what's valid or what's invalid in much in the same way that mismatches today with MSAG and ALI would return a report that says where an ALI record doesn't match an MSAG record and where that needs to be resolved. So again, in the future, that's why it's so critical to be able to populate the fields correctly, do the GIS data cleanup, make sure the attributes are right in there, and then also to look at the results of that those MSAG ALI GIS synchronization checks and reports to be able to clean up the GIS data and also to identify areas where the 911 provider data might be the one that's incorrect as well. But anyway, that's what this location validation function does, and it uses the GIS data to be able to do those checks. And then the next two items that are functional elements that use the GIS data are what's called the spatial interface, which we talked about before. That's basically, it's not a functional element, but it's a process by which the GIS data is taken from what you provide, and it's converted from the GIS data model format into the format needed by the next generation 911 systems like the LVF and the ECRF. This, again, does a machine-to-machine translation, and it provisions GIS data for these other components, and it uses OGC, the Open Geospatial Consortium, GIS Data Standards for that data exchange. So those were some examples of what they use. And then lastly, there's something that's called an MSAG conversion service. That's how data is going to be exchanged between legacy 911 systems and next generation 911 systems. So in this case, this MSAG conversion service could take a next generation compliant data source or from a phone record or anything else within the 911 network in NextGen, and then convert it back so that a legacy system could use this. At some point, that will go away once all systems are next generation 911 capable and ready and accepting data in that format. But in the meantime, this MSAG conversion service will also use the GIS data to be able to help with that conversion process. All right, and for the last few slides that we've got some information on how to participate in the public review. NENA has a website. The link is here at the bottom of the screen. By clicking on that, it'll provide a link to the full PDF text of the data model document. Again, it's an 86-page document. It also provides information on how to upload your comments. You can upload comments individually. For people that are on NENA workgroups, you can actually log in and provide comments in bulk, and there's an option for that. But the GIS Data Model Working Group asks for a few different things whenever you're looking to submit a comment. First off is, if there's a concern, please clearly articulate your concern. They have sections for putting up to, I think it's like 7,000 or 8,000 characters. So if you can describe what the problem is that you see, and then also what the some other supporting references, examples, and the reason for your concern, that's extremely helpful whenever they're going through and adjudicating the different comments that are submitted. Every single comment that is submitted to NENA for the public review comment period, and not just public review, but any part of the document review, any official comments that are submitted must be addressed by the work group. So they go through each of these comments one by one to be able to look at the issue, identify the concern, see if it's something that they missed or overlooked or need clarification on, and then look at how it needs to be resolved in order to address the concern. Whenever you're submitting a proposal, or submitting a comment, don't just say what's wrong with it. Definitely still include proposed suggested text on what it should say or how it should be rewritten. That's extremely helpful when trying to develop a document and trying to get feedback, have a successful resolution of the comment that you've submitted. In some cases, if you have more than one option for how to resolve the issue, that's helpful for them because they can then talk through those different scenarios and come to a potential resolution on how to address the comment or concern. Also, if it's a complicated question, so for example, some of the comments I had submitted previously, they were pretty lengthy in terms of the comments, of the nature of the comment, and because of that, they had asked me to be on one of the calls and just to call in whenever my comment was discussed. So if you've got something that's not just a brief suggestion or comment, but something that may take a little bit to describe or to flesh out, definitely let them know that you'd be available to be able to call into the work group call and explain the comment that's there. And then also, if something may need to be addressed as a future development work, that's one way to provide feedback. That way they could say, they could add your comment to that future development section, but also say that this is not something that they need to address right now, but that they would still get to it in a future version of the document. Looking back at some of the previous standards, like for example, the I3 standard at the NENA Standards 010 document, that's now in the second version has been released for that. That was earlier this past fall. And then looking historically back at some of the other GIS data standards and documents that have been released over the years, some of those have gone through 7 or 8 or 9 official releases. So the GIS data model is going to be probably very similar to that. We'll have an initial final release, but then as soon as they finish that release, they'll be going back to work looking at how they can improve upon that for the next version, for version 2 of the document. And again, continually working on that over time. So if there's something that needs to be addressed, but maybe it can be deferred until the next round of the document, please feel free to note that it could be deferred for future development work. So whenever you go through and click on the NENA website here for comments, what it'll do is it'll bring up a screen like this. It'll have a link for the PDF in the middle of the screen where you can download that. And then also it'll show all of the other comments that have been submitted. So as of this afternoon, there were 35 comments total that were submitted. It shows the subject of the comment. There was a comment number that they have, the name of the person who submitted it, and the date. So in this case, like I've gone through, and I know I've personally submitted about 6 or 7 different comments for the document. But you can look at the other comments that other people have submitted. Why this is really helpful is because whenever you have submissions from multiple states or multiple local governments on the same issue, the committee, the working group sees that as having more weight than just one comment submitted by NSGIC, submitted by NENA, submitted by someone like VML or VACO, or a municipal league, or Association of Counties. You can have multiple people submit the exact same comment. Another item that's helpful with this is that you can review submitted comments to look at the topics or the format. So if you have questions about how you want to submit a comment, you can look at what other people have done. And then finally, the NENA work group put out a reminder that if there's anyone who's interested in standards development and helping out with that, you can always join the work group and help resolve the public comments and be a part of that process. That information is available from the NENA website for anyone who's interested. And again, these work groups are ongoing on a number of different issues. But again, this was an opportunity for people who were interested in being a part of that and who had a very strong interest in development. They can definitely participate. And then finally, wanted to provide a slide with a link to, I believe this is 8 different NENA standards that are related to GIS. So we've mentioned the CLDXF document, the I3 document there. There's a standard that's out there talking about how GIS data is provisioned and maintained and provided from what you provide to the spatial interface and then what it provides to the next generation systems. There's a data management requirements document which talks about how discrepancy reports are created and provided back to various parties, whether that's to the 911 service provider, to a PSAP, or a 911 authority. And so that document was also recently released in the past year and gives an indication of the different types of discrepancy reports that would come back. There's also an informational document that NENA has talking about how to develop site structure address points and different ways to do that. So if, again, if you have projects that are working on address point data, so just like Steve said, in Virginia we're looking at having both center lines and address points as being required layers. That site structure address point informational document may have some guidance on some recommendations or different ways to be able to build address point data or improve upon address point data. There's a document and a working group that's currently ongoing that's developing best practices for GIS data stewardship in Next Generation 911. I know there's at least 4 or 5 people from Virginia that are on that work group, and they're looking right now at how, primarily at how to do best practices for PSAP boundary development and maintenance. But again, in the future, they'll be looking also at things like centerline and address point best practices as well for data stewardship. And then finally, the last 2 items that we've got are GIS data collection and maintenance standards. That's see how the document number goes from a NENA, INF, REQ, or STA document to a different numbering convention. These last 2 are older documents, but they're still relevant today. The first one that you have is the data collection and maintenance standards document that gives some standards for how to collect and maintain GIS data for 911 purposes. And then the last item that's listed is a document that talks about synchronizing GIS databases with MSAG and ALI. So especially this last one was one that was instrumental in the statewide MSAG-ALI GIS synchronization and data analysis that was done last year. It was a very, very helpful resource for that. Again, there are many other NENA standards, but these are just a handful of some of the ones that are most relevant to GIS within the 911 world. Each of those does have a PDF link to where you can go download the standard if you're interested in that. With that, I believe we're at the end to be able to answer questions. So, Melissa, I'll turn it back over to you and open it up for questions.
Thank you, Brian. As Brian said, before we close, does anyone have any questions for him?
Is there somewhere that we can download this presentation?
Yes, the presentation will be available on the VITA ISP website soon. Takes a little conversion process, and once we get that done, it will be on the website.
Thank you.
You're welcome.
And I believe for the webinars, we typically do a recording of the webinar, but we also have a link to the slides. And if we need to I think we can put a link to the actual PDF of the draft document as well as where to go for comments so that people have a link to have all that information in one location for where you need to go.
Anyone else? All right, then. Well, thank you, Brian, and thanks to everybody for your participation in the webinar today. And as Steve said, if you have any feedback or any ideas that you have for future webinars, please let us know, and we can provide that for you.
And Melissa, one more thing just to add. If there's any other questions that come up as you're looking through the review period, again, data model is open for public review through the end of February. I believe it's February 28th is the last day for comments. So we basically got about 2 weeks for public review comments. So if you're going to submit a comment, definitely please submit those in the next 2 weeks. But if you have questions or something's confusing or trying to understand what it means, feel free to reach out and ask for questions. Again, contact information is on the ISP website as well. But feel free to reach out and ask that, and be more than glad to take the time to help talk through and work through the different questions, concerns, or understanding what's in the document. So back to you, Melissa.
Thank you, Brian. Well, if no one else has any questions, then I hope that everyone has a great rest of your day, and thank you again for your participation.